Alright, Physics 2018, video number 5. This is Mr. Lewis. I didn't intend to make 5 videos. This one will be short. It's just part B and then number 24. So, in the last one, in my rush, I attempted to tell you that you figure out the efficiency of this ramp by doing the AMA divided by the IMA. That is the equation that is in the sheet up top. The actual mechanical advantage is 1.25. The ideal that we got in this beginning thing over here that we had to use to actually do this equation, we figured out from our information given that the IMA is length divided by height is 2.5. So we got an efficiency of 50%. Now, if it takes 2,000 joules of work to push the crate up the ramp, how much work will actually be done on the crate by the machine? So this is talking about the other definition of efficiency, the one that says that the efficiency equals work out divided by work in. So it takes 2,000 joules of work to push it. So that's you. That's the person doing the pushing. That's the input. And then the machine, by the machine, that's your key, that is the output. So the output is the thing that we're questioning, the thing that we want to know from this part B. So work out is our goal here. The efficiency we got from the other problem was 50%. So the work in was 2,000. So this is really easy. What's 50% of 2,000? It's 1,000. So the answer is work out equals 1,000 joules. You're only going to get 50% of what you put in. That's very simple. At least I hope it is. If that's not simple to you, I'm very sorry. I didn't mean to insult you while you're trying to study for your test. So moving on to 24. All right, this is the hard one. This is one that I set up to be hard intentionally. Well, okay, it's not really hard, but it is a complex machine, and I only did one of these as a belt work. But remember, when you have a complex machine, you got two simple machines hooked together. And that's basically what a drivetrain is. So a drivetrain connects wheels together with a belt, so it effectively makes you make a wheel and axle out of two wheels. They have their own axles, but they're not the things that are actually turning. You're using one wheel, and then it turns, and the belt forces the other wheel that it's attached to also turn, which basically makes your, air quotes, axle the other wheel that is being turned. So we're going to hook two of them together in this case. So I'm going to have part A is the first wheel and axle, part B is the second wheel and axle, and then part C is the total of everything together. So A, suppose the first drive piece has a larger wheel with a radius of 0.5 that turns a smaller wheel with a radius of 0.16. What's the mechanical advantage of this wheel? So let's go to wheels. Now, this is going to have a very common misconception in here. So this says the wheel IMA is the radius of the wheel divided by the radius of the axle. That's not necessarily true. It usually works this way because 99% of the time, you want to turn the wheel. You want to turn the bigger portion of the wheel and axle so that you can get your actual mechanical advantage. You want this to be increasing your force. So you want to use the longer distance on the outside, on the wheel, in order to lift something with the axle. But that doesn't have to be the case. The main thing is that it shouldn't actually be radius of wheel divided by radius of axle. What it should really be is the radius of the thing that you turn divided by the radius of the thing that it turns. So if you turn the wheel, then the wheel turns the axle. Wheel goes on top, axle goes on the bottom. If you, with your hands, turn the axle, then the axle will turn the wheel. So you turning the axle would go on top of that fraction, and the wheel would go on the bottom. You're going to get a decimal mechanical advantage because you're turning the small part in order to turn the large part. But in that case, maybe that's what you want to do. Who knows? Maybe you want to turn this larger object with the smaller object. That's basically what bike pedals do. You turn the little tiny gear in order to turn the much larger wheel of the bicycle. So all in all, an actual bicycle does this exactly. You put in a large amount of force to get a large amount of distance out of the machine. So, but let's just stick with what we've got. So wheel goes on top, axle goes on the bottom for this one. So what we had in the equation was it said that the wheel radius is 0.5 and the axle radius is 0.6. So IMA equals R divided by R, and so IMA equals 0.5 the wheel divided by 0.16 the axle, which is going to give you an IMA of 0.5 divide 0.16. That's going to be 3.125. Okay, so there's our IMA for the wheel. So let's, oops, that's, why did it do that? Okay, there, that's what I want. I'm going to go back and bold all these things that I wanted. Efficiencies, that. These are bolded. I can do that later. Right. So now the second train, the second piece of the drivetrain, has the smaller wheel that we had before. This small wheel is going to turn a larger wheel. So this is what I was saying a second ago. This is a case where you would want the quote-unquote axle to go on top instead of having the wheel go on top. So this is a little bit more complicated of a question. That's the reason why I made it the last question, because it requires you to think a little bit. And that's, I don't think this is too far out of line for you guys. This is not by any means like an honors level like question. This is still in everybody's realm of thinking. So the small wheel is going to turn the large wheel. So you're going to get a disadvantage. It's going to take you more force in order to get the larger distance. You're not really using the machine for its intended purpose. You're using it for a different purpose. So you're going to get a decimal mechanical advantage. So just be prepared for that in advance. So in this case, our R over R is going to be, it's still the same equation. It's still IMA equals R divided R. The radius of the first thing divided by the radius of the second thing. Or normally wheel divided by axle. But this time we're going to use IMA equals the wheel in this case, we're turning the 0.6, and then it will turn the other wheel of the 0.33. So that's going to be a mechanical advantage, or disadvantage, or however you want to phrase it. In this case, of delete 0.16 divide 0.33. It's about 0.5. That's the way I intended it for it to be. It's roughly 0.5. So this IMA is going to be basically a half. You get half as much of your force. So basically, if you turned this small wheel with a force of 100 newtons, it would turn the larger wheel with a force of only 50. But the advantage is it turns further. It turns a larger distance. So you can, depending on what you want, if you want more force or if you want more distance, that's what machines are for. They're going to trade one for the other. The whole point is the trade-off. You lose one and you gain the other. If you lose force, you gain distance. If you lose distance, you gain force. Whichever the case may be. So yeah, now we've got the mechanical advantage of the second wheel set. So ultimately, when we combine these two together, remember what I told you before, if you think all the way back to the bell work that we did on this, you should still have it written down somewhere, I hope. When you do a combined mechanical advantage, all that you have to do to get a combined IMA, and this won't be one of your equations, so this might be something you'd want to write down. Combined IMA equals individual IMAs multiplied together. Yeah, individual IMAs multiplied together. So the individual IMAs that we had were 3.125 and 0.5. So the answer to this is just going to be 3.125 times 0.5, which just equals 3.125. Clear piece of junk. 3.125 times 0.5 equals 1.5625. That is the combined mechanical advantage of this overall drivetrain. There you go. That's the answer. If there are any other questions that you may have, hopefully I will have already answered them in class. Hopefully your studying is going well. Good luck on the test tomorrow, or good luck studying for the final if this is what you're watching this for, because these will still be useful for the final exam, because this is all going to be on there. All right. So good luck with everything. Mechanical advantage is not that bad. Stay calm. Parse out what you need to know. Go find the equation. And then just make absolutely sure that you plug things into the right spot. Because these are as simple as your equations get. Once we get back to electricity, we're getting back to ugly equations again. So we'll see what happens. Okay? Don't forget to copy this into your copied study guide if you copied yours, because it won't update correctly. You need to have that other efficiency equation. I'll try to point it out in class. Thank you for watching. Farewell for now.